Okay, as we all grab our seats, welcome everyone. Thank you for joining us for today's panel discussion, The Quiet eVTOL Revolution. I'm Jim Sherman, and I'm the Director of Strategic Development at the Vertical Flight Society, and I will be the moderator for today's discussion. This session is hosted by the Vertical Flight Society, the leading technical society for all things vertical flight, including helicopters, gyrocopters, advanced rotorcraft, and of course, eVTOL. VFS has been leading the eVTOL revolution since about 2013 when we collaborated with NASA to plan out the first transformative vertical flight workshop in 2014. This workshop included about 100 attendees, all of which are pioneering advocates for and researchers and engineers promoting the advancement of electric flight for many aerial missions, especially air taxi and emergency services. We encourage you to participate in our activities related to eVTOL, as there is a place for all to be part of this revolution. Our program sponsor today is eVTOL.com, powered by Vertical Magazine. Unfortunately, our sponsor, Jen Evans, was unable to attend this week, and we wish her well as she recovers. But we also thank her and Vertical Magazine for the wonderful pastries in the back. For today's program, I think it is interesting to note that we have the same speakers that we had 2 years ago when we did this panel. Unfortunately, or interestingly enough, each of these speakers represents a different company today, or a different organization. So we have Juliet Page from Blue Ridge Research, Mark Moore from Whisper Aero, Ben Goldman from Archer Aviation, and Rex Alexander, who is our newest panelist, from 5 Alpha will be on our panel today. We'll have a couple of short presentations to provide some background information, and then we will open up the discussion to all of you to get more information out of our panelists. First, I'd like to start with a couple of videos, one from Joby and one from Archer, to demonstrate the potential of these vehicles and then break into the panel discussion. So can we have that first video? Thank you for that video. You can see that the Joby vehicle does have some significant noise reduction that makes it very viable. And so with that, let's go ahead and get started with the panel discussion. Our first speaker this morning is Juliet Page. She is a principal engineer with the Blue Ridge Research and Consulting Group and is chair of the HAI Fly Neighborly Working Group. She has over 35 years of experience conducting research on transportation noise, much of that with the Volpe National Transportation Center. Juliet, please come up.
Okay, well, thank you, everybody. I'm happy to be here representing the Fly Neighborly Working Group. Okay, so I'm going to just cover a little bit about the Fly Neighborly and Environmental Working Group Charter and what role it is that we play here with HAI. I'm going to talk about state-of-the-art acoustic modeling for eVTOL vehicles, talk a little bit about the source component modeling, operational modeling, and some of the challenges with modeling tools, talk about the importance of flight testing, and hopefully convince some folks to help share data so we can more rapidly advance this industry, and talk a little bit about advanced air mobility needs and fly neighborly opportunities. So I will let you read this yourself, but Fly Neighborly Committee is all about informing pilots and operators for best practices that they can do in their daily operations to help reduce the noise impacts on communities. We have an element of our Fly Neighborly program that also includes community outreach and engagement so that operators can be proactive engaging with the communities. This empowers communities and helps them feel like they are being heard. And the simple act of, noting with the community that may have a concern about noise or operations in their area, telling them, hey, we're going to fly this way over the street or avoid going over the ball fields or whatever their concern may be, it makes them feel empowered. So I will encourage all of you to get ahead of things before they turn into, legal or litigation issues. And this is very important. We have this new blossoming industry of eVTOL, and I think it's a challenge to everybody to be proactive with the community engagement before we have any problems so that the community, thank you, feels like, that they're being heard, they're being listened to, and they have a stake in this new forthcoming industry. So the Fly Neighborly Working Group, our charter is to help facilitate that. So a little bit about acoustic source modeling. So, excuse me, it's an important piece of the design process. The manufacturers and the vehicle designers and the operational designers, they need to understand analytically what's happening with their vehicle, with their designs, what the influence of that is. There's a whole host of first principles or physics-based models, empirical models, component-based models, and all of these come together for all the various noise sources on the vehicle. There's some high-powered computational fluid dynamics, computational aeroacoustics analysis methods. There are tools and techniques out there for oralization and making sounds, listenable sounds out of these vehicles. A lot of these are on the forefront of technology in the design space and in the modeling space, and there's a lot of really cool active research. And this is the part where data comes in, because we need to have confidence in these tools and these models and understand the best way to provide feedback from a community metric perspective to the designers and the operational designers and the people figuring out the configuration of all of these vehicles so that they can make appropriate changes and improvements to the vehicle, taking the community impacts into perspective. That's just a little notional graphic of, you have various noise sources. You have rotor noise emission from the rotor itself. You may have wake interaction. So some of the wake coming from one rotor can influence itself or another rotor. It's all configurationally dependent. There's also broadband noise sources. And some of the complexity with the electric vertical takeoff and landing vehicles, you have a lot more rotors. You have a lot more opportunities for interaction. The way the RPMs of the rotors is controlled is quite different than a conventional helicopter. And so you can have all sorts of interactional effects because you have moving frequencies. And you have broadband and stochastic effects. So You can't have they may not emit a steady kind of a sound. It may be varying in response to what the rotors and the control systems are doing. And some of those things are perceived by people as beats or modulated tones. And there are some public, perception effects. Also, folks need to take into account what the background noise is. So one of the things that's different about the electric VTOLs is a propensity by the manufacturers and the operators to bring noise into the forefront. And I'm really thrilled to see that. So often noise and acoustics plays second fiddle to all sorts of other performance goals on aviation vehicles. So seeing noise in the forefront, especially community acceptance, as a critical parameter for this industry is really heartwarming, because I've been working in acoustics for more than 30 years, and noise is generally an after effect, so it's really great to see it up in the leading edge. Although that means we really got to get our act together here for the prediction and the modeling and get the confidence in them. So what you're seeing here is an animation of a notional eVTOL from an analysis I did with NASA late last year. And it's just showing the impact of, this is a overall sound pressure level in the community. And I'm just covering a small portion of a notional operation. But there are tools and technologies that will allow you to look at full simulations of the vehicle. And as the vehicle is changing its operating state, its noise emission changes, its directivity changes. That's why the shape of the footprint changes. So you see this particular analysis is for a 5-foot receptor, so you see some interference ground effects, that little rippling at the end. We need to consider sound in 3 dimensions. There's a lot of talk about operating these vehicles in urban environments, in soundscapes where you may have vertical buildings. There's a need for assessing metrics for human response, human acceptability. We tend to talk more about acceptability of these as opposed to reducing the percent highly noise. That's like the old paradigm for aviation acoustics. We're now talking about let's get it down to an acceptable level so that it blends into the background. So now we need to take into account ambient noise and what is the background in the environment that it's going to be operating. Is it operating during rush hour, morning traffic, when you may have higher ambient levels? It may be easier to hide your operational sound in the background. Or are you talking about an operation late at night when it's naturally quieter? Are you in an urban or a more rural area? So now we need to take into account the ambient soundscape. And there's a lot of research going on on how to quantify that, how to measure it, and how to assess what these vehicles are going to sound like in those types of environments. So I mentioned a few times the importance of flight testing. NASA did a test with Joby last year, and these are some slides I borrowed from Kyle Piccioni at the NASA. He presented at the NASA Unmanned UAS Noise Working Group meeting. And so there was a number of flight tests. So the dots represent microphones, and it's a 2D array of microphones on the ground. And these are typically how we do research tests. And we fly the vehicle along a level flight path at a certain operating state, and we can also vary the operating state of the vehicle. And having a 2-dimensional ground array allows us to characterize what the source emission is, the directivity of it, because it's not the same in all directions. It may not even be symmetric, right to left, depending on the vehicle. It also allows us to look at some of these stochastic behaviors. How are things modulating in time? As the vehicle is flying along, the control system may be modifying the trim state in response to environmental conditions or what have you. And so how is that varying the source emission as it's flying along? So all of these information is really important from the science and the physics perspective so we can get improved models and tools. But they're also used for development of standards and guidance and looking at regulation and also certification. There's going to need to be some development. I know that's underway at the FAA and other agencies looking at certification, and I'm sure they would welcome some shared data as well. Having the data allows us to play these what-if scenarios. So we're coming up with best practices of how do you measure these vehicles? Where do you put the microphones? How many do you need? How dependent is it on the particular vehicle? So all of this stuff is to encourage you to help share data. Now, I understand there's a lot of competition out there, and that's why a lot of people tend to be hesitant to share data. But it's really critical that data can be shared, at least in working group forums, and perhaps maybe you can't share the raw data, but you can get involved in some of these standards and best practices committees and bring your experience with your vehicle and show what you're finding if we look at some tests and procedures and standards that we're trying to develop so that we can develop this as an industry and move things forward. So I've talked about a number of things here, and I'll get a little bit back to what Fly Neighborly is doing. So noise certification is under the jurisdiction of the U.S. federal government, and they're going to be likely to leverage and extend existing procedures, and there's a whole body of status on that, which I'm not going to get into. Airport-compatible land use for existing airports is also under the U.S. federal jurisdiction. However, when we get to heliports and vertiports, especially new ones, those are often subject to local jurisdictions, state, county, local townships, or what have you. And there can often be a patchwork of those across the nation. And that can make it difficult if you're trying to design some operations and figure out where you can site a new vertiport to introduce these vehicles. There could be a whole patchwork of regulations you need to worry about. So one of the things we're trying to do with the Fly Neighborly Working Group is to develop some recommendations and guidance so that we can hopefully have something out there that local jurisdictions can decide to adopt if they so choose. Having been an acoustical consultant for many decades and working in noise, I've seen examples of noise ordinances for racetracks or other kinds of things around the country, and they can be a mishmash patchwork. And I'm sure some of you that work in the acoustics fields, you've seen some local ordinances, and they really make no technical sense because often the folks that are putting these jurisdictions in place don't understand decibels and logarithms, and they just may grab something out of the ether, and it really is not applicable to what they're trying to do. We're hoping to set the stage to avoid that kind of stuff. So anyway, where the Fly Neighborly Working Group is right now, we have drafted what we refer to as a Rotorcraft and Urban Air Mobility Noise Exposure and Communities document. So it's intended for new, not existing heliports. It suggests the DNL threshold relative to ambient for what we call a just noticeable difference. It builds upon former guidance that's been out there. It's in draft mode. It's being reviewed by the Fly Neighborly Working Group, and we've also shared it with several other HAI working groups, and so we're in the process of HAI internal reviews, and hopefully within later this year, I'll put it that way, we will be able to incorporate any revisions from the HAI side and have that released as a document from Helicopter Association International after we go through the appropriate board reviews and have it released. So we are seeking input from the other working groups, and I'll just do a shameless plug here, our working group meeting is this afternoon. If you'd like to come, we'll be discussing that. So again, this will be applying to new heliports. It's expressed as a relative change in the DNL threshold relative to the ambient noise that exists in a current community. And there was some earlier documents that FAA had issued in the late 1980s, I think it was 1983, an FAA advisory circular that had some recommendations. We basically took that recommendation and reduced it by quite a lot to come up with this recommendation for siting of a new facility where none currently exists. So that's what we've been up to, and I guess we'll take questions at the end. Is that right? Okay, thank you very much.
Well, that was a great lead in to our next speaker, who appears to us virtually. That's right there on the screen for us. Is Ben Goldman. He's coming to us from home for personal reasons. And he is the acoustics manager at Archer Aviation. He started his career at Bell Helicopter before transitioning to Joby and then on to Archer. So Ben, go ahead and take it away.
Thank you, everyone. Thank you, Jim, and thank you, everyone, for the patience in supporting me on this. I'm actually going to have a challenge following Juliet with this. She was quite thorough in the summary of where we are with the state of things. What I can say is that Archer is very focused on this. I've been a strong advocate for the noise presence of this vehicle from the onset. One of the things that attracted me to the company was their interest in making the noise a focal point and realizing that it is a critical aspect of the design of this vehicle in terms of integrating it into a market as we see it. The thing I think is probably most important to focus on after everything Juliet said is a gap that sort of exists right now in quantifying the value of these changes that we have. We're slowly learning how to quantify public acceptance and annoyance, but the question becomes, how much is a percent, how much is a dB worth to the design of the vehicle? And that's been a challenge in driving the noise down as low as it can go while still being able to close the business case. I don't have a lot else to add, actually. Juliet covered most of the points I wanted to cover. We're really focused on trying to make this vehicle blend into the background, so the ambient level is very much of a focus. Understanding how to mix the noise sources in such a way that we don't have any dominant tones, anything sticking out over the background is critical, and very much dependent on understanding not just how the tools can support the design, but understanding sorry, give me a second. Understanding not just how the tools that are coming out of the industry, coming out of work like what Juliet is doing can inform us, but understanding how our testing can feed back. And so again, to Juliet's point, it's been a challenge trying to get companies like Archer, like Joby, to share that information outright. It's very much a intellectual property issue. It's very much a competitive market, and so of course everyone's very interested in keeping close chest this sort of information. I don't think I have anything else right now.
Mark is the CEO of Whisper Aero, a company that is focused on producing solutions for electric propulsion. He spent most of his career at NASA as an engineer and turned electric flight / UAM evangelist, and was a key member of Uber's Elevate program. So, Mark, all yours.
So I've been in 2 years of hibernation, so I thought I'd start off by introducing myself. And this is the very first time that Whisper Aero is making a presentation, so I'm going to talk a little bit about Whisper Aero. But it is awesome to be back and to be around peers who I enormously respect. Seeing Ricarda there, it's just like, it's great to be back. This is the first conference that I've been to in so very long. So as Jim mentioned, I was at NASA for 32 years, the entire time focusing on VTOL and UAV technologies. And the last 16 years of my career focused on nothing but the invention of distributed electric propulsion and getting it into flight demonstrators to prove out how it's different and what it can do. And so you can see some of the aircraft that I led, all the way from the small GL-10 UAV that was a tilt-wing distributed electric aircraft, to Leap Tech, which is along the bottom. Looks like a Mad Max truck, but it was the very first distributed electric propulsion full-scale wing that had a total of 32-foot span, 18 propellers, and about 360 horsepower. And again, all of these projects were done on shoestring budgets because no one believed in electric aircraft at that time. So the entire budget that I was able to put together for Leap Tech was $2.5 million. And just to get that wing built and put into the 40 by 80 wind tunnel, which is the only tunnel that it would have really fit in, would have cost more than our entire budget for the test. So we did really amazing creative things. That's one of the projects where I was able to work with incredible companies like Joby, who actually converted the truck, developed a really cool airbag system, because look, we were inspired by those before us. And Scaled Composites had done pickup truck tests and shared that data with us, and you could see all sorts of jitter from the truck bouncing on the dry lake bed when they had done it. And so Joe Ben Beavert said, oh, we need an airbag system that will just dampen all that out. And lo and behold, they developed that, and it did. And we got the very first distributed electric propulsion data set for the wing, and showed just how remarkable this new technology tool set is to fundamentally change how aircraft can be designed. And that led, in fact, that data set led to being able to pitch the X-57 back in 2015 and getting that program started. And then, you know, as I was seeing the data come out from these different experiments, it was clear to me that it was time for these technologies to go beyond NASA and to be commercialized. And that is when we started working with VFS in a tight partnership to really get industry excited about this new technology frontier. And so one of the outreach efforts I did shortly after that was with Uber, and managed to go directly to their CEO and tell them about this exciting technology and the future it could bring. And they loved it. And so very shortly after that, I was hired in to lead Uber Elevate, the engineering team there, where we didn't just focus on a vehicle, but understood the bigger picture of things and how an entire ecosystem needed to be formed to establish a new transportation paradigm. And so it was a combination of 10 different vehicle partners, many different infrastructure partners, working with the FAA, different local governments, and really trying to put all the pieces of the ecosystem together. But then COVID hit. And so Uber divested all of their hardware projects, all the way from scooters to autonomous cars. Yes, even flying electric air taxis was divested, and Joby purchased that. At which time, even though I think the world of Joby and the other pioneering electric VTOL companies out there, we have Whisk and several others represented here today that are doing awesome work. But for me personally, I saw that it was time to go back to what I loved, and that is creating new technologies. And really wanted to fundamentally look at how electric motors and controllers wanted to be integrated and push air, and not just accept that propellers were the only way to do it. And so created a company called Whisper Aero, and for the last year and a half have been working with an incredible team of engineers, where I've been able to pull what I think is the best team that I've ever worked with. We're up to 21 engineers. Did a crazy thing that Joe Ben Beavert inspired me to do with his tech campus up in the Redwood Mountains of Redwood trees in the Santa Cruz Mountains. And that is I bought an old resort in a small town in Tennessee that happened to be right adjacent to the local airport, and created our own Whisper Aero Tech Campus. And so we have been able to really focus in on inventing this new technology set, while also having the luxury of a small airport that lets us do all of our testing right there. And when we get stressed out, we can jump in a kayak on a gorgeous lake. So really, couldn't say enough about the team that we've assembled. But I'd really like to jump into, what drives us and what guided us during this reinvention of distributed electric propulsion. And one thing is that, as Juliet said, one of the cool things about what's happening in this industry is that noise is leading. It's not an afterthought. And that, I think that really sends a strong message of how much we want this to be a community-friendly solution. And look, most of us, if not all of us who are in this, are really big believers in different things, such as that the future is electric. We're in a really exciting time over the next 20 years where the fundamental nature of our energy solutions is changing from oil to electric. And it creates an incredible time of opportunity for new technologies to assert themselves across industries, especially transportation. Many of us are also huge believers in that with electric, we have the opportunity to change how this energy is created and using sustainable ways for that energy generation. Another tenet that we believe in is that it seems obvious that the world is constantly pushing people closer and closer together. And so if you look at across especially the 5,000 public use airports that exist in the United States, there's so many neighborhoods and communities that have grown around them that actually they're pressuring those small airports and in many cases making those small airports go away because of noise complaints. One of our investors happens to be Robert Downey Jr. Yes, Iron Man has invested in Whisper Aero. And this is, as we reviewed the technology with the Foothill Coalition, which is an investment focused on low carbon solutions. As we reviewed with him and his associates, this is the wonderful statement that Robert Downey Jr. came up with that we're big believers in. And that is the future needs to be as compassionate as it is compelling. And noise is a big part of that, right? If you respect the community that you're serving, you're going to have quiet operations. Along with that, something again that Juliet said, and that is, it's about localities. And it's really important to recognize that as any new vertiport is created and passes zoning and passes approval, as Rex will tell you, they have the final voice. They have the final vote. And if you don't get their buy-in and approval, then that vertiport will not exist. And I will say and extend this even further and say that for any heliport that's existing and small airports where operators are trying to fundamentally change the nature of the operations and go to scale, then it really requires a new level of buy-in from the communities. And that we live in a future where, especially in Europe, it's already happening, where noise will be budgeted. Any one of these portals will have a noise budget that it has to live with. And you can even see in the UK where they've adopted, I believe it's called N70, where the number of operations at that local airport, you're only allowed to exceed 70 dB a certain number of times throughout the day. And I think that as we get to these new metrics that Juliet was talking about, that you're going to find all of us have to live within the confines of noise budgets. And it's important that all of us are working this noise problem because of that. One loud aircraft can use up the noise budget for a single location with one operation. And the last tenet that we're big believers in is, look, if this market is going to make a difference in terms of transportation, then it needs to be able to be cost effective and affordable to a large number of people. And that only happens with economies of scale, and that means that we need to be focused on solutions that can get to scale. Otherwise, it's a niche market for the wealthy, and personally, I have no interest in that because I'm not wealthy enough myself to enjoy it. So, so one of the mantras, and I'm going to explain this more as we go into the next couple of slides, is we are absolutely committed to making community and environmentally friendly the rational business decision in transportation, in getting when you're getting into the air. And this is a big statement because it invokes a lot of different things that need to happen, and very much makes me want to explain why I believe this is called the quiet electric revolution. And I don't have VTOL there because, you know, whether it's urban air mobility or regional air mobility, it's the same revolution, and we're all in this together. And that is really finding ways for aviation to make a difference in people's lives in a daily kind of way. And for that to happen, it's not just noise. And there's a whole bunch of necessary and sufficient conditions that must be satisfied. And as you look at the helicopter industry, or again, the regional air mobility industry, you know, right now, essentially, compared to the automotive industry, this is a cottage industry. It's a niche market, right? The production volumes are very low, and the vehicles are extremely expensive. And when you look at the operating costs, they're extravagant. And in fact, for helicopters and PC-12s and, you know, other aircraft, it is really only the wealthier people who can afford those type of operations. There's other challenges where the ride quality of small aircraft and smaller helicopters are not great, you know, and that comes everywhere from how much you're bouncing around as you're flying within the weather, to cabin noise, to the seating comfort, to how many different routes you're able to choose from, and the frequency of those operations. So there's a lot that needs to improve in terms of that user experience. And I know from having done 4 different surveys when we were at Uber Elevate with thousands and thousands of respondents, that there are customer biases out there. And especially when it comes to open rotors and open propellers. Across all 4 different surveys, that was one of the top things that came back, is that normal people are very uncomfortable with big spinning things in close proximity to them. And most people are very uncomfortable flying in an aircraft or a helicopter that is dependent on a single engine. And honestly, those are rational perspectives. And across all these things, so I mean, and here we're talking about noise, but all of these things are very, very important. And especially when you look at noise, you look at this list, there's really only one way for people in communities to actually complain about this list. And that is when one of these helicopters or one of these aircraft flies over and they hear it, and they can lodge a complaint relating to that noise. But often, at least in my opinion, that noise is being used as a proxy for another complaint. And that is, it's some rich guy who's flying overhead, inconveniencing me with his noise while he is convenienced himself. And I will never be able to take advantage of that. Or there's a single engine helicopter that's flying over my head. I don't know if it's going to come down in my backyard, and I get no derived benefit from that risk. Any one of these preconceived notions that could exist really can only be communicated as a complaint in one way. I heard it fly over, I didn't like it. So oftentimes noise is the catch-all, but we've really got to fix all these things together to make a difference. And especially the picture in the background that you see there is San Carlos Airport up in the Silicon Valley, where I lived, and I know the airport really well. And think about it, you had all these local people with picket signs complaining because Surf Air was trying to fly 20 times a day from a small airport that had significant setback distances. That was just 20 times a day, right? I mean, if we're really going to take eVTOL or regional air mobility aircraft into the mainstream where the economics can be great, we need to be doing a lot more operations than 20 times a day at locations. And so we need to be really focused on making sure that these aircraft are small and that we don't get all these complaints across different reasons into that catch-all bucket. So what I'm really excited about is, with my last slide, is what we've done. And first I want to say, just because in an aircraft or eVTOL or eCTOL, conventional or vertical takeoff, or seaplane based, just because it's electric doesn't mean it's quiet, right? You get quiet through really complex engineering, where if you look at it in terms of rotating a device that producing thrust, it's about the tip speed, it's about the loading on those blades, it's about the frequency content, the fundamental frequency that's created by that tip speed. There's so many different factors that go into this. So I will say, I've seen and heard most eVTOL and eCTOL aircraft out there. They're not all quiet. And we really need to treat each one individually and encourage all of these to be developed to be as quiet as possible. What I will say about Whisper is we have already built and tested many of our propulsors. We've actually designed 9 different ones and built and tested 5. And we have been able to achieve the goal that we set out at the beginning of this, which is to be able to map into the background noise of ambient soundscapes. And I will say it's very different, for instance, what that standoff distance and blending into the noise is based on how much thrust you're producing and how big that aircraft is. So if it's something as small as a leaf blower, then the critical distance is about 50 feet. And that's where the ANSI noise standard for leaf blowers is actually tested. If it's a drone, then it's of less than 55 pounds, it's more like 100 feet. And I can tell you, I've tested a lot of drones, and you can still hear those at 500 feet and beyond, even the lightweight ones. But what I'm really excited about is that we've started to integrate our propulsors, and I'm actually going to show for the very first time the first test bed that we've built and are actively flying with our propulsor technology on it. And so this is the Whisper drone. No one's ever seen it before, and we're actively flying it. It is a 55-pound ISR drone that we're fortunate that we've been able to receive over $2 million of government contracts, DoD contracts, to develop the propulsor for military needs. We're also looking at how to integrate this on larger aircraft. We've made some comments in public about a whisper jet that we've been designing. I'm not going to show that today. That's going to be at a future event. But what we're really excited is that we understand now not only this new distributed electric propulsion technology, but how to integrate it. And fundamentally, it's very, very different than everything that you're seeing today in terms of open prop solutions. We're also excited that we were selected to be part of the Air Force High-Speed, or AVWorks, High-Speed Vertical Takeoff and Landing Concept Challenge. So we have an award that we've been granted for that to now take the new propulsors and integration technologies that we've developed and apply them to the high-speed VTOL needs. So we've got a lot of different exciting things happening, but I will say as exciting as flight testing is of new concepts, it all goes back to really hard work that's being done by individuals such as Juliet, David Josephson, Ricarda, and others to come up with better ways of measuring what's going on. Because you really cannot make progress unless you have metrics that can track appropriately. And frankly, just talking about DBA levels is imprecise and leads to a lot of failed understanding of noise. So it's really exciting that HAI and others have been developing new metrics that take into account not only how loud something is, but the type of noise with the context of background noise, because it's always that delta over any background noise that creates annoyance. Also, how frequent the operations are, as well as when those operations are taking place, because it's far more annoying to have noise disturb you when you're sleeping late at night or early in the morning than if it's during the midday and you have an expectation of some level of noise. So I really am excited that we finally are getting to new metrics, which we're actively using in the minimization of our propulsors to achieve the best acoustic performance. But again, one key message is it's not just about tackling low noise. It's really about making sure all these different ingredients can stack up to be able to have vehicles and transportation ecosystems that can make a difference in our lives. So I'm just going to close with this one last comment, and that is that we've actually achieved what we set out to do a year and a half ago. Our technology is working, and we are actively looking to work with OEMs and different supplier partners to bring this into their future product streams. So we could not be more excited that we're at an inflection point to help the industry achieve this really, really important goal. Thank you.
All right, thank you, Mark. Very, very exciting indeed. Okay, our last, we finally come to the Q&A part, but let me make sure that I do properly introduce Rex here. Rex Alexander is currently the infrastructure advisor for Vertical Flight Society. He's also the chair of the NFPA Committee on Vertiports and a member of several ASTM committees and the U.S. Helicopter Safety Team. He's a helicopter pilot and has flown offshore missions, EMS, and is a former Army aviator. And he comes with a great deal of experience and will have great insight to any of the questions that you may have. So this is the point where we will turn it over to you to query our panelists, including, if we can get Ben back up on the screen. And we can go from there. So if you have a question, raise your hand. I'll bring a microphone around. I'm certain there's several that are going to come up right away. So if you give me just a second, and I'll get the microphone, and I'll come to you.
Hi, Tony Tesla with Supernal. I'm just curious on the HAI book that you have coming out, the draft. One, is that available now outside of the regular group? And then two, what's the standard that you're saying there's a new standard that you're applying for residential areas? Is that 3 dB above ambient, or what is that? And is FAA involved in those discussions?
So at this point, we are not releasing the document outside of HAI working groups because it is a draft document. The intent is to eventually get HAI board approval and have it released as an HAI document. So I'm not really going to give you a whole lot of details on it. It is less than 3 dB above ambient. If you think about it this way, if you have a vehicle that matches ambient in terms of the level, and you add them together, it'll be a 3 dB increase in ambient. We are not recommending that high of a level. It'll be less than that. We'll be talking about it at the working group meetings. They are, official HAI meetings this afternoon, and public is allowed to attend them. So I'll just leave it at that, so I don't get myself in trouble with HAI board. But it's not a. It's not going to be like a standard or something like that. It is a recommendation and a guidance document that jurisdictions, entities, whoever could use for some information. It's not a book. It's a 9-page document in its current state, and it describes the thought process behind what we're recommending, and it lays out essentially the acoustics. There's equations in there on how to calculate it and how it is computed relative to ambient and how where it comes from and the thought process behind it. So it's not a it's not a regulatory thing at this point in time, but when we're ready to release it, we will be more than happy to also share it with the FAA.
This is a question for Juliet.
Oh God, I'm in the hot seat today.
Juliet, I was wondering if you could share some of your impressions. We've been talking about the last 10 years of evolution of electric propulsion technology, but perhaps also the last 10 years of analysis capability, data gathering capability that has been brought to bear to understand higher fidelity directivity information on terms of emissions related to aircraft conditions, let's say, on approach, departure, flyover, and perhaps where you think you see those analysis capabilities going in terms of going beyond modeling, right, and into assessing where in our communities we expect to see perhaps detection and disruption over our ambient soundscapes. And so just some impressions perhaps from you on how that workflow has been going and where you see it going.
Yeah, thank you. I think a big piece behind all of the analytical advances has been computer technology. And the horsepower, the computing horsepower that we have at our disposal, the improvements over the last 10 years. We can, when you're computing acoustics, computational air acoustics, the fidelity at which you need to do the modeling is commensurate with the wavelength. And higher frequency sounds require much denser grids. You can get away with smaller grids for lower frequency sounds. It's just the nature of the physics and capturing the wavelength of the signals. And so with the computing technology, we can just throw a whole lot more horsepower at it. And that allows us, on the aerodynamic side, to model these complex rotor systems with their wakes and have these feedback loops of the influence of the turbulence and the wake-induced turbulence and unsteadiness. And we're able to capture a lot of that now in the modeling and on the analytical side and you need to still figure out what of the moving air is going to radiate as sound into the far field. And there's some, techniques, like using the Fox-Williams-Hawkins equation, for example, that allows you to project that. So now we've got this near-field piece, and that's been advancing very rapidly, and there's been a lot of work done with the wind tunnels and flight tests and beamforming arrays to look and examine individual elements of the noise on a complex vehicle, which allows us to fine-tune our models. There's still a number of empirical-based models because we don't have the computing horsepower to look at all the fidelity. So we have some, simple empirical-derived models as well that are in the mix, and we recognize that, hey, the more and more you change the technology from where those empirical models were derived, the less applicable they are, which is why we're always like screaming, give us more data, give us more flight test time, give us more wind tunnel time, give us more testing time, because that allows us to advance everything. The next step after you understand what's going on in the near field in the vehicle and how your control systems and your flight operations and your trim state and there's infinite variables with these complex vehicles. What is propagating away from the vehicle and how is it propagating away? And then you need to account for what is it going to sound like? What is the acoustic experience going to be at a receptor? Then you start to bring the human into the loop. And you thought you had big error bars on measurement and modeling techniques. Once you put the human in the loop, your error bars just get bigger because every human interprets it differently. So you get into the field of psychoacoustics. That is a real term. And we kind of jokingly say they're a little psycho. I kind of fall into that category. But that gets into all the human perception and how people interpret the sound. And if you think just about music, and you think about, Western European music, Mozart and Bach, and then you think about the types of sounds if you listen to Oriental music or Indian music, it's very different tone content, very different chords. And somebody with a different background and coming from a different culture interprets the sounds and the dissonances different. And so now you bring into this the cultural differences of what these sounds sound like. So there isn't just a stock human, but we need the tools and the methods and the techniques to assess this. So one of the pieces that's also being worked in is called sound oralization. So how can you take these analytical tools, propagate the sound down to a receiver, and then listen to it in a realistic way, and now put yourself in a city background, sitting out in a park, in your own background, inside your house. What is it going to sound like in these different environments? And so you get into the whole public perception side and the need to do all these community response testings. And there's ways to do with labs and headphones. And that's where the current science is. And it's still kind of the Wild West in terms of metrics. It's not going to be a standard fixed, you think about a DNL contour around an airport. This isn't going to be anything like that. It's going to have to look at the time variability, the time of day. You're going to need to understand how the ambient going to vary throughout the course of a typical day. Is a weekend different from a Monday morning? You're going to have to understand this. So when you get to the flight operations part, and as Mark mentioned, you have a noise budget, how are you going to spend that noise budget? How much noise can you accumulate over multiple operations? It's going to be additive. But we don't know how to add it up necessarily because, the science is still out there on how to do that. I think the technology's improved tremendously. Computing horsepower is totally behind all this, and I'm sure it's behind all the design work as well. So, we can thank all of our, chip designers for giving us more tools at our disposal. But every single step on this process needs to be validated and verified. And we're always talking about, okay, where's the long pole in the tent? Where do we need to spend our research dollars and our flight testing dollars? What is the most critical piece from the human perception side? If there's a little small element that you're never going to hear on the ground, don't waste our time and effort working on that. Let's figure out what are the key drivers. So hopefully that answered.
Thank you for such a thorough answer, and it's great to have you as such an active participant in this community. We're really grateful for that.
Well, thanks, it's fun.
I have a follow-up question actually now for Mark and Rex, but Mark more specifically. So Mark, good to see you again. We worked a lot thinking about community engagement while we were at the Uber Elevate project together. And you spoke a bit today about sort of the non-acoustic elements of noise perception, and I think that there was probably a bit of emphasis in your presentation today about those factors which weigh negatively, right, on people's perception of noise. Perhaps there's some opportunities to buy back some of that perception as we return value to communities. But we also spoke today a bit about blending into the ambient. There's certainly troublesome questions there too when you think about noise equity, right? Loud places and adding more noise to loud places, is that equitable for communities? Could you speak a bit, right, to how we provide value to those who we affect with these new products, and then bring that into the conversation about noise? And Rex, I'm sure you, as part of that, you work a lot with hospital heliports. And so, it's always not a direct benefit to those affected, right? And so maybe if you could speak to that too after Mark weighs in.
So actually, Rex has a lot more practical engagement on this, but I'll say two things. One is, a recent example was in the San Francisco Bay Area, right, with the Zuckerberg Hospital trying to get approval for their helipads, right? That's an example where that operation should count as a negative dB, right? Because it's actually saving children's lives. So there's all sorts of operations that can be serving the community, and it's not just an individual who's deriving their own benefit, but there's a societal benefit that we all, receive value from. So, that's just one example of it. Getting to your other statement, I will say one of the interesting trips that I did when I was at Uber Elevate was going down to Melbourne. And they've had a helipad in a downtown location for many years. And it's right in the middle of a park. And I actually went on a helicopter ride, toured the city, talked to the operator. And they said, isn't this the perfect place for a vertiport? And we could put all sorts of helipads all along this river park. And I said, no, it is the worst place in the world for a vertiport. You don't want to be putting them in quiet, scenic parks where you're obviously going to be making significantly more noise in the background. So it is interesting that, this isn't just about the vehicle or the technologies. This is about how it all comes together to serve society in appropriate ways at appropriate locations.
So, in my world, in 25 years of putting heliports in or all over the world, and now I used to sit actually 3 seats down from Mark at Uber for a short period of time when I worked at Uber, having these discussions with NASA and the FAA. One of the things that we go into, and I know Juliet has spoke to this and so did Mark, is, public perception is driven by opinion. And opinion then drives acceptance. And one of the things we deal with is, have you ever heard the noise before? And that's one of the things that we deal with helicopters a lot is, if it's new and different, most of the times it's unknown and scary. So one of the things that I see many people in this space do themselves a disservice is they don't take the time to understand what the perception of the public is, test that perception, and then actually do a kind of a community outreach and engage the public. Most of my clients lately, I get called after someone started a Facebook say, stop the heliport. And I said, well, at that time, it's probably going to cost 5 times what it should have the first time around. So I didn't show any pictures because you did not want to see me being actively burned at the stake in front of public zoning commissions and public council meetings. And having done testimony for heliports in like downtown Chicago with 500 angry citizens, emotion drives the day. You have to get out in front of what you're trying to do with facts and science. And part of this is the individuals in the community drive the opinion that then makes the decision. The decision makers really aren't the public. They're the ones the public elected. And the elected officials are scared to make unfavorable decisions. The public drives that. So it's a two-pronged effort in that space. You have to have a public outreach. You better have a marketing department that understands that, and you better go out and pound the pavement, because if the public sees your project on the evening news before you've talked to them, they're going to go to the internet and try to educate themselves. And we all know that everything on the internet is 100% accurate. And you will fail miserably. And I've had clients, I've been able to salvage some of those over the 20-plus years by education. But when you have somebody, and it's, my acoustician is stronger than your acoustician. I've seen that battle take place on the public stage, and it gets real ugly really quick. So having that education prong of any project is huge. When the end of the day goes to making the decision, you have to make sure the people that are elected are comfortable with the decision, or they're going to say no every time.
Hi, everyone. I'm Tori Maliska from WISC. Question about other methods of reducing noise and the associated negative outcomes. For the whole panel, what are your thoughts on using other infrastructure, other systems external to an aircraft to mitigate noise?
Can you give us an example? So I'll tell you, one of the crazy conversations, we had many of them at Uber Elevate. I think Rex and I were responsible for this one, where I said, Rex, what if you could have a helipad and you could shoot a water fountain all the way around the periphery to create essentially a water curtain. That could essentially dampen the noise within that final part of the approach. Look, we kicked around crazy ideas like that, but not the safest thing to have a 20-foot high waterfall completely around a helipad. Even a 4-foot fence, causes most of the accidents for helicopters. So I don't know what wild ideas others have here, but it's really hard when you're flying in and over. You've got a lot of exposure, and so it's really hard to remediate except with distance. The more setback distance you can have, the better off you are.
Yeah, I've done some work in noise cancellation technology over the years. And if you can co-locate the canceling wave, basically the opposite sign, with the noise source, it'll work perfectly. The problem is, the amount of energy you need to create that cancellation wave is equivalent to the amount of energy you need to create the noise in the first place, and they have to be exactly at the same location. And so it really doesn't work physically. It just doesn't make sense from an engineering perspective. Then you say, okay, well, we'll put a bunch of microphones around the thing and we'll broadcast them out. Problem is, if they're not coincident, you get addition and subtraction. So you have this phase interference. So you may be able to quiet it right there, but you're at least doubling it over there. So how can you fine tune that? It's very difficult. And you're now dealing with like dynamic systems, which they're not steady state. It's easier to cancel something steady state. It's not as simple as your noise canceling headphones that you can wear on the airplane or something like that, where you only have a little bit of sound coming in and that battery's enough to cancel it just right at your ear. It's not trying to cancel it over multiple dimensions. So I don't think that technology is really a viable approach for this. At least nobody's been able to figure out how to do it that I've heard of.
In looking at what you're asking, we do take noise into consideration in developing infrastructure. I actually said in a meeting one time, and somebody actually raised the question, and somebody else said, well, we'll just buy everybody in the neighborhood noise canceling headsets. I'm like, I don't think that's gonna work. That being said, you can design the infrastructure to overlay with noise producers in the area. So we look for high-density traffic areas that will mask that noise. So railroads, if you put it in over a highway, things like that. The one thing that we can do with the approach departure path is we can curve that to avoid noise-sensitive areas. Now, that also comes with a caveat. If you get the opportunity and you're interested to learn another piece of this, is how you fly the aircraft matters a really, really lot. Being a brand new warrant officer in the Army, I learned really quickly that my little Bell 206 Jet Ranger could make as much noise as a Huey if I flew it in a specific way, i.e. 500 foot per minute rate of descent, about 60% torque, and a slightly descending left-hand turn. I could get a blade slap that would shake the windows. And did that on occasion at 2, 3 in the morning in certain neighborhoods. That being said, conversely, you can fly your aircraft to be a lot quieter if you know how to do it. HAI has their Fly Neighborly program, great program. They have a great educational program online that you can take for free that talks about that. One of the things they speak to is when you're turning the aircraft, you have to keep in mind, is it a counter-rotating or clockwise or counter-rotating rotor blade? Because which way are you turning, left or right, depends on what the advancing blade is doing on the outside or the inside of the turn. One way will actually increase noise, one will actually decrease noise. While your rate of descent has a big impact on the blade slap. So education on one side on how to fly the aircraft in conjunction with how you design the infrastructure can hurt you or help you if you pay attention to it.
Hi. Hi, Garrett Aviation Week again. Hi, Ben. Question for you. You hinted at this a little bit, but I wanted to know if you could elaborate more on the trade-offs between making an eVTOL quieter versus making it more efficient. What sort of trade-offs do you see in propulsor design or the number of propulsors, and to what extent do those, is it a big trade-off or is it only minor?
It's always a trade-off. Everything in engineering is a trade-off. You can't get any, well, unless you've invented something novel, you can't include something or change some part of the design without affecting and likely compromising some other part of the design. Oftentimes I make the very simple analogy of the number of propulsors as you threw out being comparable to the number of blades on a wind turbine, right? Why 3? Why not 2? Why not 4? It comes down to manufacturing, cost, noise. All of them have to balance out. We're very much dealing with the same thing. So there's survivability aspects. Of course, increasing the number of rotors increases survivability or chance of survivability from an accident. You can potentially decrease disk loading, which can affect the noise dramatically, and lower tip speeds as you increase propellers. Though, of course, you increase the complexity of the overall system, which has its own problems, and makes it that much more difficult to prove the reliability of a complex cascading failure. So, yeah, constantly.
Hi, Larry Mattiello, S4K Aviation, up in near Poughkeepsie, New York. I have a question and for the panel, and it's an old question, but I'm going to bring it up and see if any work's being done and how we could still approach this issue. Let's assume we're operating a safe, quiet vertiport operation at a local airport surrounded by a very noise-sensitive community. And at 10 o'clock, 11 o'clock at night, Rex, the National Guard comes in with their Black Hawks doing whatever practice and exercise they're doing, and it's loud and it's noisy. And all the community knows it's a helicopter, it's at the airport, and it could be us. How are we, and I know this question's been asked a lot over the years, how are we still approaching the military on flying neighborly and the noise-sensitive issues? Because it really is, it's been happening more and more, at least in our little airport community.
Well, I know one thing that has helped in that respect is technology, and that particular technology is ADS-B. When I go into a community and there's issues, my opposition knows the tail number of every aircraft that has ever flown over their house in the past couple of weeks. And they'll produce tracks of the aircraft from radar images because they're tracking them on their laptop computers. So in that space, what we look at is who was it, what were they flying, when were they flying, and what's their contact information. Part of that then goes into the educational standpoint. I think if you can get high enough in the hierarchy, you can actually make an impact. I work closely on the U.S. helicopter safety team with our friends in the Coast Guard and the DOT, and they're receptive, but you need to get high enough to make that downstream flow of information make an impact. If you just go to the local people, you may not get the impact you're looking for. You need to actually have it pushed from the top down. Most people that I work with, you know, if there's life-saving operations going in and out at that moment in time, don't have too much of an issue with it. But if you're doing training and you picked your airport to do that training, maybe there's a better location for that training to occur away from those sensitive communities.
I'll just make a, excuse me, a mention about the government operations versus civilian operations. There's been some issues in the Washington, D.C. area about all the military helicopters. And Congress commissioned a study investigation, I don't know what the right word is for it, and the GAO, Government Accounting Office, Accountability Office, whatever they stand for, did some investigation into the situation in the National Capital Region. You can probably Google it and find it online. They issued a report, I think it was last year, 2021, on it, and I actually got interviewed by them for the Fly Neighborly work. And my understanding is that currently there's no budget because Congress budgets have been on continuing resolution or something like that. So nothing's happening right now, but in the future, there may be a look at applying Fly Neighborly principles for DoD operations in the national capital area. Don't know whether it's going to happen or get funded or, you know, what's going to come of it. In helicopter operations, especially when it comes to training, it's fixed wing operations too, they generally trump everything in terms of importance and mission readiness and mission need. But if their mission is, you know, getting stuff from point A to point B, they often have some flexibility in how that can operate. So there's some hope, and you might just look into that, and it could be useful for you.
If I could follow up real quick, and probably, you know, good advice for us all. As Rex touched, I actually have been using education with apps like Plane Aware and Flight Aware and things like that, or Plane Finder, where I'll actually track it, and I'll actually email the information to the local town supervisors or local politicians and say, hey, you may get calls tonight about helicopter noise. It's not us. It's your, you know, United States military out tonight practicing. And I actually gone into the community and actually shared with them these various apps that if you happen to see or hear, you could actually, as Rex, as you said, you could track it yourself. So it is really a matter of communications and making the local community aware. They're not going to be happy, but at least you realize it's not us.
Yeah.
So,
Education is key for all of these issues.
Yeah, exactly. Thank you.
All right, last question, I believe, as we've run out of time.
So hello, thank you. I was very impressed with the presentations. I'm new to this industry. My name is Teresa Davidson. I'm a consultant to PS&S, Architects and Engineers in New Jersey. I have, all my career has been all in airport design, airport terminals. So I'm really excited about this new industry as a continuation of what I know how to do. And specifically, I'm interested on the passenger. And I've heard very little spoken in these sessions that I've attended with regards to the passenger and the user, but you did mention a lot, and I know that the business of noise, obviously, it has to do with us, right? How we're going to perceive this new industry and whether I'm going to use it or not. So back to the question from the lady, no, Tori, from Tori. I was thinking, you know, again, back to the passenger, back to the user that's going to be flying, riding these vehicles. We're going to have facilities, and facilities have materials, and materials can absorb sound as well. And so I urge the industry and you all that are in the forefront to remember that there is going to be a facility there that's going to be moving these passengers, having comfort for them, having the passenger flow, the experience, et cetera, and as well as probably all those, materials that can support how we're going to experience the vehicles, landing and taking off when we're going to be like this close. I mean, that they're going to be small facilities, and I'm going to be as far as that, I think, from what I've learned in the brief yesterday or the day before. It's not a long distance. So materials can help. Architecture can help. So I urge you to think about that as well.
No, and you bring up a very good point. I've actually looked at the acoustic properties and materials that we build things out of that support helicopter operations, and you can hurt or help your case depending on the selection of and what material the properties have. So, yeah, building and design is huge in architecture when it comes to support. I would agree.
And I do want to address actually that terminal experience really quick. I promise I'm going to keep it super short. What's really exciting about eVTOL and electric motors is that instantaneous production of torque. On the other side of it, that means we can shut these aircraft down as soon as they've reached their landing site. We can taxi on, by other means, right? And not be radiating so much acoustic energy into the community just from the ground operation. If you think about the New York City heliports today, they keep those rotors turning. They hot fuel, they do all kinds of things that really, honestly, aside from flight, it's probably the ground op that actually produces so much impact. And so, we're really excited about the opportunity that eVTOL provide in that regard as well, and that we can shut down and then turn it right back on only when we're ready to fly.
I hope everyone has enjoyed this session. It's been very educational, I think. Ben, thank you for joining us. You still there? Yeah, okay. So a couple of things. If you've enjoyed this session, VFS puts on other sessions at various different places, including their own. I'm going to do a quick rundown, and you can learn more if you pick up the magazine in the back that has a list of our events in it. But we have a hydrogen aerospace workshop coming up at the end of March in Long Beach. We will be at AUVSI for a session there. We'll also be at the Ohio UAS Symposium, or AAM Symposium, I guess they renamed it, at the beginning of April in Columbus. And then, of course, we have our annual forum in May. And then Rex and I have started working on our 6th infrastructure workshop for September, as well as VFS works with the Cafe Foundation to put on the Electric Aircraft Symposium, which is held 2 days ahead of EAA AirVenture in Oshkosh. I believe this year is July 21st and 22nd, or thereabouts. So if you have an interest in more than just eVTOL, but eCTOL and hybrids, and just going to Oshkosh to watch the cool aircraft there, please think about joining us there. As I mentioned, we have the magazine in the back. That's an old version. The new version actually has, and Ben, unfortunately you can't see it, it actually has your aircraft on it. So if you join as a member and do it quickly, you'll get this magazine to be able to review, which came out, it's our January, February magazine, so it'll still be available for a short time for new members. If I missed anything else, Mike will correct me afterwards, so that's fine. I want to thank our panelists, Juliet, Mark, Ben, and Rex, for their expertise this morning and for their patience with us getting started. And Ben, thank you again for joining us virtually. We hope everything works out well for you. And the last little bit is I want to thank eVTOL.com, powered by Vertical Magazine, for sponsoring our food. Please partake as you exit. And of course, our panelists will be around, I believe, for a few minutes if you'd like to interact with them directly, as will Mike and I. So thank you again for joining us, and look forward to seeing you again down the road, whether at one of our events or somebody else's. Thank you.